Hello, my name is Landon Palmer,
I am Ethan Moser.
and we are electrical engineering students at Utah State. This is the video covering our ECE 3710 microcontroller's final project. So to begin, we're going to go over a couple of the inputs and outputs that we'll be using on our project, which is our 4-axis or 4 degrees of freedom robotic arm. There are stepper motors that control each joint or axis of the arm. Now, this robotic arm is controlled through potentiometer joysticks. The x-axis and y-axis of each joystick will control a stepper motor independent of the others. The motors that we decided to use are 28BYJ48, which is the same model of stepper motor that we have used throughout previous lab projects. However, we have found that after 3D printing and assembling our hardware, the stepper motors did not have enough torque, which Ethan will go into further as to other problems that we ran into. Other motors that could have fixed this issue or helped with the torque would have been a NEMA 17 or an AM 3248, which were larger, more powerful stepper motors. Now, I'm going to draw out a bit of a block diagram to give a better understanding as to what's going on with our hardware. So we have our microcontroller, and it is connected to the 4 drivers for our stepper motors. Now, these drivers are required so that we do not draw more current than we can on the GPIO pins that each of these drivers is connected to. So each of these drivers was designed to go to a stepper motor as such, and each pin on the microcontroller for our stepper motors is controlled independent of one another. Now, for our joysticks, we had to create a voltage follower circuit that involved 4 op-amps. Each op-amp is connected to a separate axis of our joysticks. So this top op-amp could be seen as the x-axis of this joystick, this op-amp as the y-axis. These op-amps were needed so that we could create a voltage divider to limit the amount of current that we are drawing or sending via the external power supply that drives our design. So this power supply will externally drive not only the joysticks, but it will also drive our stepper motors. Now, we are using an external power supply so that we can get adequate voltage. The stepper motors and the joysticks require different levels of voltage, 3.3 versus 5 volts. Now, that would be an issue if we were to drive them on the same power supply internally, and it wasn't worth the risk to drive our design through the internal options that we had through our STM32 microcontroller. Now, I will hand the time over to Ethan to discuss more in depth the ADC that we used to convert our signal from the potentiometer joysticks to the microcontroller, thus driving our stepper motors.
As Lennon has discussed earlier, we had a couple other problems with this project, thus we weren't able to finish it fully. As we can see here, these are the problems that we've had with the ADC. We were able to figure out the initialization. It took a couple attempts, as well as the reference voltage. This is something that we believe we are still struggling with, which will be shown in the debugger that we will show in a sec. The range difficulty, we are having a problem of finding the correct range from 0 volts to 3 volts. Currently, we are only able to bottom out at a value of 5A3 in hex, and we are unable to get above a 9D4, I believe, in hex. So due to these problems, we were unable to completely finish this project. Now we're going to go into the debugger to look at the current values that we are getting and what we believe is going on. As we can see in our debugger, we are currently able to run it, and it does not drop below the hex value of 5A4. And when we drop the joystick, as you can see, nothing occurs as well with our value. Now, if we go up on the joystick, as we can see here, it ups our value to roughly 9.8D in hex. This is allowing us to move the motor step by step, as we can see here with these lights. But due to the low value unable to be read, we are unable to get full functionality out of this stepper motor. So we believe that this is possibly the reference voltage, and due to our time constraints, we have not been able to do enough testing due to holdbacks on 3D printing, and as well as designing the robotic arm in its complexity.
So to conclude, this has been our video discussing our microcontroller project, which is the 4-axis, 4 degrees of freedom robotic arm. Today we have discussed our overall design using separate voltages from an external power supply to drive our circuitry, and GPIO pins to control our stepper motors and to be controlled by our joysticks. Now, our design, although we were able to get the hardware functionality correct, the software to control our stepper motors was not quite as we had hoped or designed.
Due to the problems that we have gone over for the ADC, if we were to attempt this project in the future, we would put a little more effort in our ADC at the beginning of the semester to be able to figure out how to initialize it correctly, as well as figure out other ways to debug it, as well as get to designing and 3D printing the model faster to be able to avoid delays with other students as well, 3D printing. So these are all things that we found. Thank you for watching.